Hi, Mardina. Can you hear me?
Yes.
Okay, good. Okay, so your question was in the pre-lab of the Galaxies lab, how do you calculate the distance between the two galaxies? Okay, so let me just go to that page. Actually, I'm wondering if you have the earlier edition. Which edition of the lab manual do you have?
I have the current one. It's not the lab manual. It was actually in the lab when I did it.
Oh, okay. Yeah, let me see what questions. Yeah, okay. The way you would do distances is, well, you assume that the types of galaxies that you see in each cluster are pretty similar, in size and in what types they are. So if you see galaxies smaller in one cluster, then that cluster is further away. And if you see larger galaxies in another cluster, then that cluster is closer. And it's basically linear. You measure the sizes of the clusters. I'm sorry, the sizes of the galaxies. For example, the 5 largest galaxies in the nearer cluster, and you can just use a ruler and measure how many millimeters across they are in their longest axis. So this is for question 7. And then, so you write down the measurements of the 5 largest galaxies in the Virgo cluster. And then you go to the Hercules cluster and measure those and write down the lengths of the 5 largest galaxies in that one. And then you just take the average of each and then take the ratio of the averages. Let's see, I can see if I can find an image that I can pull up into the whiteboard, and then show along which axis to measure the size. Yeah, let me just go and see if I can find an image that I can capture and then import. It's looking around now. Okay, so there's actually a PowerPoint item 6 in the Lab 10 Galaxies table of contents. There's a PowerPoint, which I think is the one you use to measure the different distances. So I might actually I might be able to pull that directly into the whiteboard. Let's see if I can find it real quick. Okay, well, I need to figure out what name it is. Okay, let's see this. Oh, okay. Yeah, I found a couple of annotated images. I think I did those in WIMBA last semester with the students. Let me see if I can see where they are. Okay. Okay, hang on. I just have way too many folders here on my computer. Oh, here it is. Okay. Oh, I have to upload a PowerPoint file. Let's try this import thing. Okay. Doesn't seem to want to come up. Well, let's see if I can find the PowerPoint. Okay, I'm looking for the Galaxies PowerPoint right now. Oh, here it is. Okay. just have to find the path. Okay. Okay, I'm almost there. Okay. Okay, let me try this one here. Okay. Hi, Lenita. I just saw that you joined us. We're actually looking at Astronomy 1020 right now, the Galaxies Lab, and how to calculate the sizes. Okay, this is the first image, just the title page of the Galaxies Lab cluster images. Let's see, here we have, okay, it says Virgo cluster images A and B. I think that might just be A. Let's see. Clicking to the next one. Okay, I think that's B. Yeah, so this one is A, and then, yeah, the Virgo cluster is so close that the galaxies are large enough where we can actually see detail. Okay, and then we have a Coma cluster image, Hercules cluster image. Actually, I'm wondering if the other file, so let me import a different file, because I called the galaxies for the lab far, far away. Hang on just a second. Let's try this file here. Yeah, okay, I think this is the file we're using for the lab. So it has the same title page, and then the Virgo cluster A and B images. So both of these images are galaxies from the Virgo cluster. And again, it's just that the cluster is so close that we need two separate images to fit some of those galaxies in. Okay, and then the Hercules cluster is the one you want to determine how much further away it is than the Virgo cluster in question 7. Okay, so what you would do, let me go back to the Virgo cluster. There's a table in question 7 for galaxies 1 through 5, and one column is for the Virgo cluster and the other column is for the Hercules cluster. So essentially, you measure the sizes of the 5 brightest galaxies or the 5 largest galaxies that you can find, and just write either the centimeter readings or the millimeter readings on there. Let's see, if we take this image, there are 3 large ones. I'm going to write a note on here. So let's see, measure in, let's just say centimeters, the diameter or longest axis of the 5 largest galaxies in each cluster. Okay, below is image A of the Virgo cluster. Which is the closer one. Okay, so one galaxy here on the left side, the brighter one, is pretty round. So it doesn't really matter in which direction you measure its size. See, let me draw a line. And you sort of have to decide, because it's sort of very bright in the middle, and then the further away you go from the center, it fades out and becomes dimmer and dimmer. So you sort of have to decide to which brightness level you want to measure, and then measure to the same brightness level in all the other galaxies. Let's see, let me just put one through here. Yeah, I'm just going to say, well, I'm not going to go out to the very faintest reaches, but where you can still sort of see the brighter part of the galaxy. Okay, so then this would be your size of one of the galaxies. If you measure the length of that diameter, so let me put an arrow there. And a text box. So measure the length of this diameter, and then if you have a elliptical galaxy, kind of like the one that is a little bit to the bottom and to the right, you would measure the longest axis. So let me make a line through that too. And I'm trying to estimate the same level of brightness to which I'm going to measure the long axis. It doesn't have to be totally exact. Oops, here we go. Okay, so and add the explanation. Okay, so this would be the size, the long axis would be the size of this galaxy. Okay, and well, I mean, there are three larger ones on this image. On the bottom right is another elongated one that we could measure the size off of. Okay, oops, no, I don't want that. Okay, let me make another arrow there. And since you want to pick the five largest ones, let's see if we can find two more on the other image. So let me go ahead and save that. And again, you can measure that in centimeters. You could measure it in millimeters. You could even measure it in inches. Yes, and the actual length will probably also depend on the size of your computer screen or the resolution that you've picked. But as long as you're consistent and measure all the galaxies on the same computer with the same resolution, then you can compare them. You just don't want to say, oh yeah, I'm at work now, so let me go and measure the length of the Virgo cluster and then go home maybe to a small notebook and then measure the length of the Hercules cluster. You know, then you've changed scales and your numbers will be off. So you want to make sure that you do these measurements on the same computer. Okay, let me go to the Virgo cluster B image. Yeah, and I suppose, yeah, there's one that looks a little bit distorted, so we probably want to stay away from that one. Let me make a circle around that. Or some sort of an oval. And mark it with an arrow. Oops. Okay, in a text box. See, these two galaxies may actually be so close that they exert gravitational forces and distort each other's shape. So, you know, you could say they're so close that they could be colliding. So these two galaxies are so close. Oh, that's my daughter. Hang on just a second. Corinne? Hör mal zu, ich bin hier in einer Chat-Session, okay? Sei mal leise und rede mit Daddy, okay? Okay, I'm speaking German to them. Okay, let's see, these two galaxies are so close that they or that their gravitational forces on each other distort their shape. Okay, so we really don't want to use those for measurement because they can have, you know, really weird shapes, wisps that go on forever. So we want to stay away from those odd-looking galaxies when we measure the sizes. But for example, we can use the elliptical one that is fairly near the center. And again, then we just have to judge to what level of brightness we want to measure. In this case, it's a little bit harder. I'm just gonna, oops, wait a minute. Gotta change my pen. And I should probably pick the straight line and not the freehand. Okay. Yeah, so this would actually be a pretty large one. Okay, and then just measure the long axis in this direction. And then here on the right is actually a spiral galaxy, because you can see a little bit of texture in there. I mean, that's how you can tell apart the edge-on view of a spiral galaxy from just looking at an elliptical galaxy, because an elliptical galaxy has just stars in it and hardly any gas or dust. So you just see more stars, more densely packed in the center, and then it sort of becomes less and less dense with stars the further to the edge you get. Whereas in the spiral galaxy, you can see some structure, spiral arms, interstellar matter that make for brighter and darker patches. So that's definitely an indication that here on the right we're having a spiral galaxy. But since we're looking at it edge on, we would also measure its long axis. Okay. Okay, so something like that. So then you just measure the long axis of these two galaxies. That gives us a total of 5. I'm going to write that up here in red. Yeah, for a total of 5 sizes from the Virgo cluster. Okay, yeah, let me save this real quick. Okay, and then let's go to the Hercules cluster. Okay, now I've scaled the images, so you know this galaxy is a lot further away. So you want to you see here the ellipticals are much smaller fuzzes, and the spirals are much smaller circles or slivers. And again, you'll see a couple of galaxies that seem to be colliding and distorting each other, so you want to stay away from those. Yeah, I'm just going to circle a couple of them. See, that didn't work so well. I have the wrong color. I want it green. Okay. So these two here are colliding, so you probably want to stay away from them. Okay, so these two might be colliding also. Up here, they're so close together on the upper left, that it would be hard to find the edge of one and the beginning of the other. So let me just write that up here real quick. So don't use the close galaxy pairs. Okay, well, I mean, then from the remaining ones, we can pick 5 of the larger ones and just measure their length. Yeah, probably there's one, there's an elliptical here, kind of hard to pick. Well, okay, let's start with the elliptical one up here that is next to the pair that's really close. Okay, maybe something like this. One, and we have a spiral galaxy here towards the center. Could measure that. Here's this, up on the upper left is a spiral that we see face on. So we can use that. So 1, 2, 3, and here's an elliptical, also close to the center. Okay, something like this, and then one more. Yeah, so many choices. Yeah, let's just pick this elliptical here on the bottom right. Okay. I mean, I was tempted to pick this edge-on spiral, but it also seems to be in the process of, oops, gotta start my circle somewhere else, colliding with another spiral there. Okay, so let me make a red text box here. Okay, and say you measure the length of 5 of the largest single galaxies. Okay, and again, you use the same centimeter ruler, and then write down the length of these 5 in the Hercules column. So I'm going to save that too. Okay, so now for question 7. Okay. Okay, Mardina, have you had a chance to make those measurements? Okay, great. Yeah, why don't you give me the sizes of the 5 sizes of the Virgo cluster galaxies? You can just type it into the chat box. Great. Okay, so we have, I'm going to just use a different color. 2.2, 1.4, wait a minute, 1.4, 1.7, 2.5, 1.8. I'm going to put all in centimeters. It was supposed to be blue, but apparently decided to go back to black. Okay. Okay, so let's calculate the Virgo average from that. Great. Okay, so it's 1.92 centimeters. Okay, that's finally blue. Yeah, and with the average, you add all the values together, and I know you've done that, but yeah, there's still some confusion about that. So add all the values together that you have, and then divide by the number of values that were given. So in this case, we would have 5 values. You divide all the values, 2.2 plus 1.4 plus 1.7 plus 2.5 plus 1.8, and then divide by 5, because we had 5 values that we wanted to average. And a good way of checking if you've calculated somewhat correctly is that the number that you get for the average has to be smaller than the largest number of the individual numbers and larger than the smallest number. So it has to be fairly in the middle range of all those numbers. Okay, yeah, let's do the sizes. Oh, great, sizes of the Hercules cluster. Let's go back to black. So I stay consistent. Okay, so we have 0.6, 0.7, 0.8, 1, and 0.5. And again, that's all in centimeters. I'm trying to save space, that's why I'm doing the units that way. And the average grade is also there. Okay, that would be the Hercules average being equal to 0.72 centimeters. Okay, so now the method of determining the distance is, well, if we calculate the size ratio of these averages, then that will be the same ratio that their distances are different. So in other words, yeah, let's go ahead and calculate the size ratio, the Virgo average over the Hercules average. Okay, so we have the Virgo average divided by the Hercules average. So 1.92 divided by 0.72. And that happens to be, yeah, let me just round it because I'm running out of space here, 2.67. Okay, so that means that on average, the Virgo galaxies appear 2.67 times larger than the Hercules galaxies. Okay, let me save this and clear the slide. So in other words, let's do the question 7. It also means that the Hercules galaxies are 2.67 times further away from us than the Virgo galaxies. Remember that our assumption was, that all the galaxies and all the clusters practically have the same size range. We just see them at different sizes because one cluster is further away than the other. So that was the basic assumption here. Okay, well, now that we have the factor of how many times further away the Hercules galaxies are, and we can use, I think that's question 8 now, let's see. Yeah, in question 8, if the distance to the Virgo cluster is 45 million light years, what is the distance to the Hercules cluster? So in other words, we can just multiply the actual distance in light years of the Virgo cluster to the factor by how many times further away the Hercules cluster is. Okay, so question 8. The Virgo cluster is 45 million light years away. So the Hercules cluster is 2.67 times farther away. Okay, I can calculate that in the color blue. So we just multiply those two numbers. So 2.67 times 45 million light years equals 120 million light years. Yeah, that's about right. So, let's see, I'm going to put that down here, 120 million light years. And save the slide. Okay. So you would go on then. Well, in question 9, it just asks you in general, well, if you look at the Virgo cluster, you see a huge range in sizes. You see, of course, some bright galaxies, but you also see a lot of dim and faint galaxies. Well, if you would put the Virgo cluster a lot further away from us, would you still see the same size range of galaxies? Or would there be some sort of, factor that would prevent us from seeing the same range and sizes? So, the question is, would we be able to see the very faint galaxies in the Virgo cluster if we were 120 million light years away from it instead of the 45 million light years. Exactly, yes. Yeah, we would not be able to see the faintest ones of the galaxies because they would fade out. So I'm trying to think of an analogy. Well, let's say in a parking lot where you had, trucks and bicycles and motorcycles and, cars of all different sizes with all different powered headlamps. Well, the further away you go, if you're on a bicycle and you just have a dim little bicycle light, the further away an observer would go, at some point they wouldn't be able to see those bicycle lights anymore. So, they would assume, well, it's a parking lot that probably just has trucks and cars, but it doesn't have any bicycles in it. But that is just because they're so faint that they've faded out. Let's see, then in question 10. Oh, we already answered question, wait a minute. Oh, okay, yeah, in question 9, you're comparing the faint cluster with that of the Virgo cluster. Okay, so yeah, let me bring back, that's the far, far away cluster. So yeah, save the snapshot, so I'm gonna switch it over to the far, far away cluster. And again, in this image, you can use the exact same procedure that we have just used to measure the distance of the Hercules cluster to also measure the distance of the far, far away cluster. Measure the 5 brightest galaxies, the sizes of them, and then take the average, compare that average in size to the Hercules average, and then you know how many times farther away those galaxies are. Actually, maybe I can even put a text box in here. Oh, yes, I can. Okay, so that would be for question 10. So measure the sizes of the 5 brightest or largest galaxies in the cluster below. Take the average of the 5 sizes and compare it to the Hercules average. So the same way that we compared the Virgo average to the Hercules average. Okay, so then you would calculate Hercules average divided by far, far away average. Okay, and that would be your answer. Well, that would be the factor. So the far, far away galaxies would be that many times further away from us than the Hercules galaxy. So the far, Okay, I've made up the name Far, Far Away. That doesn't actually exist. But, yeah, in order to get the technique down, the Far, Far Away cluster will be that many times farther away from us than the Hercules cluster. And then you take that factor and multiply it by the distance that we have calculated for the Hercules cluster. And switch my color again. Yes, we would multiply that by 120 million light years. So to get the distance of far, far away, multiply the distance factor from above by the 120 million light year distance of the Hercules cluster. Yes, so that's how you would get it. Oh, okay, so that would already be the answer for question 11, since question 10 was just asking for how many times further away the far, far away cluster is. Okay, so this would be for question, I'll put that a little bit further away. For question, even further away. Okay. Okay, yes, for question 11. And the last couple of questions, at least 12 and 13, they're actually talking about the galaxy collision. See, let me just save this. Okay. I'm going to type that into the chat box. For questions 12 and 13, you look for pairs of two galaxies that are so close to each other that their gravitational forces on each other change their shape drastically. So See, at this point, do you have any other questions about the Galaxies lab?
Number 4.
Okay. Okay. Yeah, I don't think I have a PowerPoint for that, but let's go back to the Virgo cluster. Maybe I can use one of those ellipticals to show how to measure the sizes or the subtypes. Let's see. Okay, I saved this. Okay. Yeah. Okay. Okay, so now in question 4, we're just looking for elliptical galaxies in particular. So let me make a text box up here. Although you have different images online that you look at, but I'm just using this as an example. So question 4. Yeah, we're just using the galaxies in this image to demonstrate how to measure their subtype or determine their subtype. So in order to determine their subtype, you need 2 measurements because you want to figure out some sort of a ratio for how squished the elliptical galaxy appears. If it's circular, then no matter where you measure it, it will all have the same diameter. But if you look at a very elongated elliptical, that's football shaped, then there's definitely a long axis and a short axis. And the bigger that ratio, the more elongated the galaxy is. So, yeah, we're going to start out by measuring the longest and the shortest axis of an elliptical. So, measure longest and shortest axes of an elliptical. And we want to keep in mind that for a spherical shape, those 2 measurements are the same. Okay. Well, let's pick this large elliptical here that I've almost typed over. And again, yeah, we sort of want to estimate to what light levels we go and keep it consistent. So there is part of this is going to be estimation, but then again, I'm not looking for exact numbers, but I'm looking for ballpark figures. So even if you don't get exactly the same subtype that I get, but if it's within, you know, 1 or 2, then that's okay. Okay, so I'm going to use this as my long axis. And let me use a different color for the short axis. Let's see, maybe use this for the short axis. And keep the color coding. Okay, so in this example, yeah, Maradina, could you measure the centimeters, the centimeter length of the long axis? Okay, so thank you, it's 3.3. Okay, and what about the short axis? Okay, 1.9. Okay, so then you would determine the subtype. I'm going to go back to red. Okay, and the formula is, okay, the longest minus the shortest divided by the longest. So let's go ahead and plug that in. So the subtype of this elliptical galaxy would be 10 times 3.3 minus 1.9. Okay, and first we want to make sure that we take this difference before we do anything with it, and then divide that by 3.3. So here we have to be careful with the orders of operation. So roughly 24 divided by 3.3. Yeah, just a little over 7 maybe. Going out on a limb here without a calculator. Let's see, I can pull up a little calculator. Okay, so 3.3 minus 1.9. Oh, 1.4, excuse me. So 1.4 times 10 would be 14. Okay, and 14 divided by 3.3. Almost sawed off the limb that I went out on. Okay, so 4.24. Exactly, that would be, for the subtype then would be 4. Or just 4. So I'm going to type that in. 4.2. Okay, so this is how you would approach it, and again, keeping in mind if we had a circular galaxy, a spherical galaxy, then you would divide numbers that are pretty much the same, so then you would come out with a subtype of 0. Or a very small one. We could do the one up here real quick. Mm-hmm. Okay, so got one axis here in purple, and then I'm going to do another axis, well, maybe in yellow. Okay, and I'm just going to make didn't want to make a straight line. Freehand line. Oops. To indicate that we're going to do the calculation down here. By the way, the dog that's barking in the background, I don't know if you can hear it, but that's unfortunately mine. Okay. Martina, did you have a chance to measure the two axes? It's actually kind of hard to see which one, if any, is longer. So let's just, say, so the long axis, that's the purple one, right? Okay, would be 2.0 centimeters. Okay. And then the short axis, 1.9, yeah, so they're really very close. Okay, so then here we would get a subtype of 10 times 2.0 minus 1.9 divided by 2.0. Oops. I'm just using my calculator application here on the computer. So 2.0 minus 1.9, yeah, would be 0.1 times 10, which of course would be 1. And that divided by 2, yes, 0.5. So this elliptical galaxy would barely have a subtype of 1. So it would be between 1 and 0. Can you just switch it over? Okay. All right. Save that slide. All right. Any other questions? Okay. Lenita, do you have any questions? Okay, great. Yeah, now that we're coming up on the final, I think there will be more people in these chat sessions as we go along and get closer. So unless something comes up, I'm definitely planning on having them next week, Wednesday and Friday. All right, well, let me stop the archive then and wish everyone a good night.